Complex number. Introduction. Complex number is the number that is bigger than every other number. Every number is a subset of R and complements a set. Example of complex number is a plus ib. X squared minus y squared is equals to, in bracket, x plus y times x minus y. X squared plus 2xy plus y squared is equals to, in bracket, x plus y raised to power 2. X squared minus 2xy plus y squared is equals to, in bracket, x minus y squared. X plus y is no factor, therefore j is equals to, let's say j is equals to minus 1 by definition. X squared plus 2 is equals to 0. X squared is equals to 2. S is the same thing as, in bracket, minus 1 times 2, which is equals to minus 1 times 2, the same thing as j2. We cannot divide two complex numbers. 5 is equals to 5 plus 0i. Conjugate 5 minus 0i. Conjugate of 5 minus 0i is 5 plus 0i, that is the opposite sign. Once there is a plus, you have minus. Zi1 is, assuming z1 is equals to a plus ib, and z2 is equals to x plus iv. Z1 plus Z2 is Z2 as, in bracket, a plus ib plus x plus iv. We say that we can only add that look alike. That is, in bracket, a plus s plus ib plus iv. We are able to collect like terms. So we arrive at, in bracket, a plus s plus I, in bracket, b plus y. Let's also look at z1 minus z2, which is equals to, in bracket, a plus ib minus, in bracket, a x minus iv, which is equals to, in bracket, a minus x plus, in bracket, b plus minus vi. This gives us, in bracket, x minus a minus x plus I, in bracket, b minus y. Let's see z1 times z2, which give us, in bracket, a plus ib times, in bracket, x plus iv, which we now, if we open the bracket, we'll be left with a x plus iav plus ibx plus I squared by. But minus 1 is equals to I squared. Minus 1 is equals to 1. Minus 1 is equals to 1. We have a x plus iav plus ibx minus by. We now have, in bracket, a s minus by plus, in I, in bracket, a y plus bx. Example, let's solve the equation, in bracket, s minus 2 squared equals to minus 16. Solution. Removing the bracket and letting the square root to go to the other side, we have x minus 2 equals to the square root of minus 1. Minus 1 times 16, it will give you minus 16. Square root of 16. We have x minus 2 equals to, my square root of minus 1 is I times square root of 16. Therefore, we now have x minus 2 equals to I4. That is, square root of 16 is 4. We now have the same thing as x minus 2 equals to square root of 16 is equals to 4 minus 1. Then s, making s the subject of the formula, you have s equals to 4I plus 2. Example, multiply square root of minus 4 times the square root of minus 9. Solution, since we are multiplying the square root of minus 4 and the square root of minus 9, that minus is the same thing as I. If you now have the square root of 4 is 2I times square root of 9 is 3I. So we times we have 6I, same thing as minus 6. Example, if you have equation 4 minus I all over 2 plus 3I, solution, we have that if the denominator, since we want to eliminate the complex number at the denominator, we now find the conjugates of the denominator. So the conjugate for z equals to a plus ib is z equals to a minus ib is the conjugate. Therefore, for the z, for the denominator, we have z for s minus 3I. Therefore, we multiply through out by the conjugate. We have 4 minus I all over 2 plus 3I times 2 minus 3I all over 2 minus 3I. If you multiply, we have 8 minus 12I minus 2I plus 3 all over 4 minus 6I plus 6I minus 9, which we now have 11 minus 14I all over 4 minus 9I. Therefore, the denominator will be having 2 squared minus 9I. 9I is the same thing as 4 plus 9, which will give us 13 for the denominator. Therefore, 11 minus 14I all over 13 will be our answer. Example, if the equation 3 plus 2I all over I, solve solution, we have that 3 plus 2I all over I times the conjugate of I is minus I over I. So if we multiply throughout, we now be left with minus 3I minus 2I all over minus I squared. Example, the equation I raised to power 5 is the same thing as in bracket I squared times I squared times I. It's the same thing. We now have which is equals to in bracket minus 1 times minus 1 times I, which gives us I. Example, if you are given the equation in bracket 1 minus 2I raised to power minus 3, we have that the solution is equals to the same thing as in bracket 1 minus 2I raised to power minus 3 is equals to the same thing as 1 over in bracket 1 minus 2I all over 2I raised to power 3, which is the same thing as equals to 1 over 1 times 1 plus 3 times 2I all over 1 plus 3 times 2